How's it going, everyone? Welcome. Euler Gonzalez, and today let's take a look at the using closure chapter from this series of book written by Kyle Simpson, the You Don't Know GS Yet series, and let's get into this. Yesterday I read about this, right? Of using closure, what a closure is, and where closures are coming from, right? From this thing called lambda calculus, which is a formal system of expressing computations using functions and applications with variables bindings. And that sounds very abstract, but the idea in today's video is that you must have is practice, or you must have experience in JavaScript, so you can understand this concept as it is. So, so our attentions, right? So up to this point, we have focused on the ins and outs of lexical scope, right? And how now that affects of the organization and usage of variables in our programs. Okay, so again, our attention shift in broader abstractions to the historical, somewhat daunting topic of closure. So don't worry, you don't need an advanced computer science degree to make sense of it. Our broad goal in this book is not to merely to understand scope, but to more effectively use it in the structure of our programs. Closure is central to that effort. Recall the main conclusion of chapter 6, which is the least exposure, or the principle of least exposure. Okay, encourage us to use block and functions scoping to limit the exposure of variables, right? So this helps our code easy to understand and to maintain and avoid some common pitfalls. So for example, name collision, unintended dependencies, in unexpected behaviors. So closures build on this approach, on the approach to okay. So closure builds on this approach to encourage use now blocks or function scope to encapsulate or to limit the scoping of scope exposure of variables. But closure builds on this approach for variables that we need to use over time. Instead of placing them in a larger outer scope, we can encapsulate more narrowing scope then, but still preserve access from inside functions. For broader use, functions remember this reference scope via closures. Again, the thing here is that closure is a way for a inner functions to remember variables reference, not its value, even after this function is executed elsewhere, right? So closure is one of the most important language characteristics ever invented in programming. It underlines major programming paradigms, including functional programming, models, and even a bit of class-oriented design. Getting comfortable with closure is required for mastering JavaScript and effectively leveraging many important design patterns throughout your code. Addressing all the aspects of closure requires a daunting mountain of discussion and code throughout this chapter. So make sure you take your time and see and ensure you are comfortable with each bit of before moving into the next one. So see the closure. So here it is describing now is what a closure is. in how to visualize now a closure, where the closure is coming from this lambda calculus. But I'm not going to list out the math formulas or bunch of notation and jargon to define. Instead, I'm going to focus on the practical perspective. We'll start by defining its closure in terms of what we can observe in different behaviors of our programs, as opposed to if closure was not present in JavaScript. Okay. So, however, later in this chapter, we're going to flip closure around to look at it at an alternative perspective. So closure is a behavior of function and only function, and if you are dealing with a function, closure does not apply. An object cannot have closure, nor does a class have closure. Thought it is function's method might. Only functions have closures. So for a closure to be observed, a function must be invoked. And here is when it becomes the things. So for a closure to be observed, a function must be invoked, and especially it must be invoked in a different branch of the scope change from where it was originally defined. A function executing in the same concept, it was defined, okay, a function executing in the same context, it was defined, will not exhibit any observable different behaviors, with or without closure being possible. By observational perspective and definition, that's not a closure. But again, for a closure to be observed, a function must be invoked. And specifically, it must be invoked in a different branch of the scope change from what it was originally defined. So a function, even if an invocation is invoked in the same scope where it was defined, does not exhibit the behavior of closure. Okay, and let's look at some code annotation with its relevant scope bubble colors here. So for example, we see chapter 2, outer and global scope red 1. Function lookup student, here we are defining is this function here. All right, that it has now a new scope that is defining here. So that's what it is. So with the students, that's an array of data. And here we are returning is now a function reference that this is now going to accept is, so it's accepting its greeting, right? The variable student that is going to compute, which is part of the lambda calculus here, it say, hey, whatever you have on a student is that a structure. I want to do some transformation here. I want to compute something. I want to find is in gonna pass this arrow function, right? So this arrow function inside, it say, hey, I'm expecting to receive now an input anytime that this function calls me for each one of those elements, and this is what I want to expect to run, right? Which is, let me check if the student ID is the same as the student ID. Student.id is the same as the student ID. All right, and if it is, I'm going to return now is that element. The question is what find does, because find will say, hey, find will find is the first element in that array, right? It says find array here. It will find is the first element in that, right? this is fine. You can say even find last index, find index as well. And for example, this is like, hey, give it the first index of that element, of the first element that you find, given this condition. So find index, find last. All right. The find last method array instance iterates the array in a reverse order and returns the value of the first element that satisfies the proving testing function. If no element satisfies the testing function, undefined is returned. If you need to find the first element that match, use find. The index of the last matching elements in the array, use find last index. Index of a value, you say use index of. It is similar to find index, but checks each element for equality with the value instead of using a testing function. Whether a value exists is an array. Exactly, whether a value exists is an array is an includes. Again, it checks each element for equality with the value instead of using a testing function. If any element satisfy the proven testing function, use sum, right? Okie dokie. Instance method. All right. Good. So here you are going to pass as a predicate here. And you say, hey, if that element that I'm passing now is greater than 45, give it to me. So reverse that array and then give it the last element that you find that is greater than 45. So in other words, is 130. Okay. All right. Okay. Cool. So it's gonna return you is that element given this particular predicate, okay, or this function call, this callback function that is creating inside of here is a closure, right? Why is this? Why is this creating is a closure here? Well, because by the time that this function is now executed here, this reference has been already evaluated here. The student ID has been evaluated, similar for the student collections. So the only way for us to see if that is true is that by the time that this function is called, especially here on the chosen student, when you call this lookup student here, and exactly when you call this lookup student here, that is going to return you now is a function, is a new instance of that inner function, right? So if we call that inner function here at that position, if these variables if these variables weren't somehow hold its reference, it will throw now an error for that, whether it's this or this. So this is the observable behavior that we can look with this, right? So the first things to notice about this code is that the lookup student here, okay, the lookup student here, outer function creates and returns a inner function called is greet student. So lookup student is called twice in the outer scope, right? So producing now two separate instances of the inner greet student, okay? Both of which are safe, all right? So both of which are safe into the chosen students array, as you can see. So both of these instances are stored into the chosen students array. So we verify that the case by checking is the name of that, which give us is the name of this function that is returning us. And when we now and when we call that, and after each call to look up a student finish, it will seem that it is all inner variable will be discarded and garbage collected. The inner function is the only thing that seems to be returned and preserved. But here's where the behavior differ in ways we can start to observe. While greet student does receive a single argument as a parameter named greeting, all right, it also makes reference to both student and student ID, as I mentioned before, right? So this inner function, the greeting student, is referencing as student and student ID, right? If the assumption that by the time that this function that it is called and it evaluate this function scope and it is variables and it is statement here is discarded, all right, we should receive is an error message by the time that we call is the instance of that inner function. But it turns out we didn't receive any reference error, right? So what does these closures do here? In concrete, observable sense, closures allow the greet student to continue to access those outer variables even after the outer scope is finished. So the observable behavior here is that its closures allow a inner functions to continue to have access to variables reference from the outer scope even after that was executed. Okay. Even after the outer scope is finished. Okay. So instead of that instance of student and student ID being garbage collected, so instead of those variables reference being garbage collected, they stay around in memory at a later time when either instance of the greet student function is invoked, and those variables are still there holding their current values. In JavaScript functions if JavaScript function does not have closures, the completion of the lookup student call will immediately tear down its scope and garbage collected the student and the student ID variables. When we later call one of the greet student function, and what will happen if greet student try to access what it thought any reference to the outer scope and closure does not exist, it will throw now a reference error, but we don't get a net reference error. The fact that the execution returns and works, it tells you that this is from the direct observation of closure, right? So the TLDR of all of this is that by the time that you so closures follow this, and so closure follow this principle, or closure follow this logic. So since the scope, so now that we know the ins and outs of scope and how that affect is the and how that affects working with variables in our programs. Closures, instead of defining as a large so instead of defining as an outer large scope where we cannot put all of the variables that we need to use over time, it held now is a reference of those variables in the inner scope, so you can have access even after the outer scope has been executed. And then you can now, at any point in time or any place in your programs, run that inner function inside of this. So the observable behavior is that the closure is created when we execute a function call. Exactly. So a function must be invoked, and specifically it must be invoked in a different branch of the scope change. In a different branch of the scope change from where it was originally defined. And a function executing in the same scope, exactly, and a function executing in the same scope it was defined, it will not exhibit any observable closure behavior. This function call, this closure to be observed, a function must be invoked in a different branch of the scope. Pointed closure. Actually, we glossed over a little detail in previous discussion, which is I'm guessing many readers miss, because of how terse the syntax for arrow function is. It is easy to forget that we still create a scope in arrow function here. Arrow function is creating another scope bubble inside of the grid student function scope. Building on the metaphor of color buckets and bubbles from chapter 2, if we were creating a color diagram for this scope, there is a for scope in the inner nesting level. For example, here. So we need a for color. Perhaps we pick orange for that scope. So the blue student ID reference is actually inside of the orange. That makes sense. Scope rather than the green scope grid student. Also, the student parameter of the arrow function is orange 4, shadowing the green 3 student here. So the consequence here is that this arrow function passed as a callback to the array find method has hold to closure over student ID rather than grid student, holding that closure. That's not a big that's not too big of a deal, as everything still works as expected. It is just important to not skip over the fact that even tiny arrow function can get into even tiny arrow function can get it on the closure body. Adding up closures. Let's examine one of the canonical examples often cited for closures. For example, like this, right? Each instance of the inner add2 function is closing over its own num1 variable with values 10 to 42 respectively. So those num1s don't go away just because adder finished. In the case of num1 and num2, right? Again, so here, this function that'll be executed by the outer function is gonna create a new invocation anytime the adder function is executed, aka creates a different branch of scope, num1 and num2, right? So a closure to be observed must happen is when the definition and the execution of that function occurs in a different scope, in a different level scope, not in the same scope, which is what happened here. So an important detail might have been too easy to gloss over in that previous paragraph. So let's reinform. Closure is associated with an instance of a function rather than a single lexical definition. So closure is associated with an instance of a function. So closure is associated with an instance of a function rather to be a single standalone, a single lexical definition. In the precedent snippet, there's just one inner add to function defined inside adder. So it might seem like you will imply a single closure, but actually every time the outer adder functions run, a new inner add to function instance is created, and for each new instance, a new closure, right? In this case, that's what it is. But again, a closure is associated with a instance of a function, not with a single lexical definition. Again, this is part of the observable Closure is associated with an instance of a function, not with a single lexical definition. But actually, every time the outer adder functions runs, a new inner add to function instance is created, and for each new instance, a new closure. But this is it, right? Closure is associated with an instance of a function, not with a single lexical definition. All right. But actually, every time the outer adder functions run, a new inner add to functions instance is created. And for each new instance of new closure, so each inner function instance, labeled add 10 to and add 42 to in our program, has its own closure over its own instance of the scope environment from that execution of adder. Even though closure is based on the lexical scope, which is handled at compile time, even though closure is based on a lexical scope, which is handled at compile time, closure is observed as runtime characteristic of functions instance. Is that the closure is observed as a runtime characteristic of a function instance. But it's because it's the observation here. So closure, even though closure is based on lexical scope, which is handled at compile time, closure is observed as a runtime characteristic of a function instance. So closure is observed as a runtime feature. It's observed as a runtime characteristic of a function instance. So a closure is associated with a function instance, not with a single lexical definition. Even though closure is based on the lexical scope, it is observable behaviors, or closure is observed as a runtime characteristic as it is. Because anytime that we run that function, the outer function, we are creating is a reference that is holding the variables reference or identifiers in the is holding is the identifiers in the outer scope, so they are not being garbage collected. But the two things here: closure is associated with an instance of a function rather than a single lexical definition. And despite that, even though closure is based on the lexical scope, it is observed. So closure is observed as a runtime characteristic of a function instance. So in both examples from the previous section, okay. There you go. Okay. Okay. We have chapter 7, using closure. Right? So closure, okay. So it all starts with closure. So it all starts is with scope. Okay? It all starts is with scope and variables. Since scope as we know, as we explore scope, as we explore lexical scope, because that's what it is at the end of the day, or the scope, the lexical scope. So as we explore the ins and outs of the lexical scope and how it and how it and how it and how it behave, or how it affect, I will say that, and how it affect working with variables and the organization of our program. Okay, so as we explore the ins and outs of the lexical scope and how it affects working with variables and the organization of our programs, with the principle of least exposure, with the principle of least exposure, or to avoid, or to use a scope to avoid overexposing variables, overexposing scopes, right? So overexposing scope variables, so we can eliminate classes of bugs. So for example, name collisions, for example, name collisions. So unintended dependencies, right? For example, name collision, unintended dependencies, an unexpected behavior by exposing is that, right? So closure say, hey, closure is built on this approach. So closure is built on this approach, right? So any for variables that we need to use over time, but what a closure is built on this approach, on the approach of a scope, lexical scope, and working with variables in our programs that affect the organization in our programs. So while principle of least exposure, what it mentioned is uh, avoid to use so avoid overexposing a scope variable so we can eliminate an entire classes of bugs. All right. So closure is built on this approach, the lexical scope and working with variables to organize our program. But for variables that we need to use, okay. So for variables, okay, that we need to use over time, and this is the key thing here. So for variables that we need to use over time, so instead of relying on an outer larger scope, okay, so we encapsulate this in a function. We encapsulate more narrowly in scope, but then we still preserve access from inside function for broader use. So we say, hey, for variables that we need to use over time, and instead of placing them in a larger outer scope, exactly, and instead of placing those variables in a larger outer scope, we encapsulate more narrowly scope, then but still preserve access from inside function. So we encapsulate them. Oh, okay, makes sense here. So we encapsulate them. So we can encapsulate them and exactly, we can encapsulate them in a narrow scope, right? We can encapsulate them and allow the function to continue to access those variables. And continue to and still preserve access. Okay, and still preserve access, right? And still preserve access inside from the inside function, But that's the whole point of the closure. All right, since with the lexical scope we look at the ins and outs of defining variables in each particular scope, and how it affect how the scope affects is the organization of our programs and working with variables here, and because to eliminate an entire classes of bugs, working with scope is by following this particular principle of the least privilege or the principle of least exposure, so we can get rid of the name collisions per scope or unintended dependencies or unexpected behaviors. So closures builds on that. Okay. Okay. So closures builds on that and says for variables that you need to use over time, instead of placing in a larger outer scope, let's say a function larger outer scope, or a global scope. That's right. Uh, let's create, because that's what it's doing here. Uh, we can encapsulate in a narrow scope and still preserve access from the inner scope, right? So this narrow scope, uh, that we can encapsulate these kind of variables and still preserve access from the inner functions to use over time. This is built on this. Okay. 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 But again, all of this is because we have now differing scope here. So we have the lexical scope, which is the place where we can put now our variables and the computation in that. All right. We have different ways to handle these scopes, whether it's a block and variables. We can also look at how to work with different syntax form, variable syntax form, and how they behave. Mm-hmm. And the different type of a scope that we can have, whether it's a block, a function, the global scope, and how this and what is the meaning of. So what does it mean, the global scope, which is a place or how in is a place where we can use to collaborate across different variables or models in our program. So global scopes, in the case of JavaScript, we have is depend on the environment. We have is the browser, the okay. We have the browser. Uh, yes, so we have the browser, and how now those variables works when you use, for example, var and functions, or let and cons. All right. The other environment is the service worker, and how you can have access to this global scope. All right. Via the self, how the function and var behave, that is attached to the global scope, but not for let and cons. The other is the top level models, or the model, the ES6 models. There is no top level scope variables that you can have access to. All right, this is pretty much like a function. This somewhat behave like a function when you define your variables and functions, and to access, if you want to have access to, well, you just now call by their identifier, or, or have access through by its identifiers. And the other environment is the dev tool as well, and Node, right? And how Node, uh, because each one of those files that you load to Node, back in the old days, it followed a way to organize code like CommonJS, that you can think of this like is injecting several properties for each one of those files, so you can work, for example, with the dir name, or the require, or the export. Okay. But now this also have is the global scope, right? So on each one of these files, you have access to this global scope. Um, mm-hmm. Mm-hmm. Okay. So it is safe to say that node that global scope in node, when it loads several files, all of them have access to the global like each file is loaded into the uh, global scope, right? So for example, so for example, this is the global scope, right? So Node.js instance, the global scope, right? Whether is a a main thread or worker or a child process, and it's inside of this that you have, for example, um, some .js, multiply .js, the basic one, some multiply subtraction .js. So all of those files will have access Actually, not quite. There is a common misconception about Node.js. Each file does not automatically load into the global scope. Instead, each file has its own model scope. How it really works. The true global scope. So Node.js instance, the global object shared across all models, and the models each has its own scope. Isolate scope, and isolate scope. But this is shared across all models. Can you take me to the source of this? Provide a link to that. I do think this is from the model wrapper. And the models here. This is on CommonJS. CommonJS models are originally a way to package JavaScript core code for Node.js. Node.js also supports ECMAScript models, standard used by browsers and other JavaScript runtimes. Node.js has two model system, but it's like injecting that. This is CommonJS model wrapper. Before model code is executed, here is describing this. Awesome. So before code is executed, Node.js will wrap it with a function wrapper that looks like this. And as you can see here, this is like model code actually living here. By doing this, Node.js achieves a few things. It keeps top-level variables defined with var, const, or let scope to the model rather to the global object. It helps to provide some global-looking variables that are actually specific to the model, such as the model and export object that implementer objects that the implementer can use to export values from the models. The convenient variables, file names, and their name contains the model absolute file names and directory path. This is what happens when the common JS models are loaded. It wraps this into a function, into it as a scope that is going to now inject is this dependency, aka making this particular file isolated or wrapping into a function scope. So the var const and lets are now scope to that model rather to the global object. And when you take and when we look now at the and these objects are available in all models. The following variables may appear to be global but are not true. They exist only in the scope of CommonJS. Exactly. The objects listed here are specific to Node.js, and they are building objects that are part of the JavaScript language itself, which are also globally accessed. So when you explore now this, the ECMAScript models, and now you have the Node models. The Node model objects, the model object, model compile catch, customization hooks, source map, and so on and so forth. So here in ECMAScript models, ECMAScript models are the official standard format here. Let's take a look at this. To package JavaScript code for reuse, models are defined using a variety of import and export statements. But its follow is this. It points me to this, to sec models. Cyclic model records. But this is section models here. Alright, so things are starting to now, okay. So we're starting to weaving all of this story here. Model and semantics. Holy hell, okay. ECMAScript models are the official standard format to package JavaScript code for reuse. So this is the spec that it follows here, right? And also model is going to throw now some syntax error here. Lexically declare name of model list contains any duplicate entries. And all of this, right? So the model request record have this. This is the specifier and the attributes, a list of important attributes record. A model request record represents the request to import a model with a given import attributes. It consists of the following fields: the specifier, and the spec describe is this the spec describe is what must be done, not how to do that. Load model request record. represents the request to import a model together with the resulting model record. Loaded model request record. And then import attribute records here. You have model request equals, right? This is part of the methods here. Model request equal static semantic model request, abstract model record. A model record encapsulates structural information about the import and export of a single model. This information is used to link the import and export to a set of connected models. Again, might go beyond the scope of today's video, but it turns out that what it's doing here with this scope, all right, or these models here, right, it's also part of the this executable code and execution context. And as you can see here, this actually explain now at this definition, it is explained now how is that the model can have access to this global scope. And it does via the outer env property that is a global record, right? It's a global environment record. So a model environment record contains the binding for the top level declaration of a model. It is also contains the binding that are explicitly imported by the model. It is outer env is the global environment record. That is interesting. Very, very interesting. So now close the gap here. Okay. All right. Okay. Cool. Interoperability with CommonJS. An import statement can reference an ES model or CommonJS model. Import statements are permitted only in ES6, but dynamic import expressions are supported in CommonJS for loading ES6 models. When importing CommonJS models, the model.export object is provided as the default export. Name export may available, and again, all of this set loading ECMAScript model using require for details. Loading ECMAScript model using require. The history. Okay. ECMAScript models. See the term in model system. And determine the model system here. All of this is because traditionally, when JavaScript was originated, there were no native way to organize the variables in a particular scope to help us organize this and make it easy to maintain. So this is why now CommonJS kicks in and say, hey, let me now provide this solutions of how can we wrap this set of instructions with its variables or this functionality, these models with whatever tool we have right now as a function scope, all right? and then inject now the dependency that it needs to be run. Okay, but now with EX6, it say I don't need none of this. All right, this is actually part of the spec, and I'm going to have is now the model records, the model environment records, that follow is the scope logic. But the outer environment is not pointed to the global environment record. Okay, so that actually closed the gap here. Actually closed the gap of our discussion of how do we now understand about the scope and the reason of the scope, and as we explore now why it is useful for us to limit the scope, the variable scope exposure, for security reasons and also to make our code easy to understand and maintain. When it comes to understand the ins and outs of lexical scope and how that affect the organization and working with variables in our programs. So when you need a function, when you need a variable that when you need to use a variables over time, so instead of putting that in an outer larger scope, we can encapsulate in a narrow scope, like putting that aside. We can encapsulate that in a narrow scope and still preserve access from the inner function. But again, this is all about is scope. Different places where you can now put your variables and a statement and algorithm to help you organize your code. Oh my god. Oh, okay. Holy moly. Holy moly. Holy moly. All right. All right. All right. Give me a second. I'll be right back. All right. This is like playing kindergarten, right? So let me put things in this scope, and this another scope, in the sandbox. So scope and sandbox are quite related topics here, right? You're gonna put everything here in the sandbox, and then somehow, if you need to connect that, well, you can now expose that. Hey, this is the thing that I want to expose to another sandbox, and so on and so forth. And anytime that as you build all of this different scope and sandboxes, and how they connect to each other, the minimal exposure, the minimal capability, the minimal stuff that the minimal stuff for them to work. So the minimal stuff that needs to, the minimal connectivity they need to work on. So the minimal connectivity they need to operate, the more robust the overall system will be. Okay. Holy hell. Holy moly, bro. Holy moly, bro. Okay. This is why closure is a very important topic here, because it allows to put now is variables in this narrow scope, okay, and still preserve access inside of the functions, and still have access inside of the function here. So a closure, all right. So a closure is created, or a closure is associated with an instance function. So a closure is associated with an instance function rather than a single lexical definition, right? Rather than a single lexical definition, because even though the lexical even though closure is based on lexical scope, all right, it is based on lexical scope, which is handled at compile time. Closure is observed, even though closure is based on lexical scope, which is handled at compile time, which is handled at compile time. Closure is observed as a runtime characteristic. Closure is observed as a runtime characteristic of characteristic of a function. Characteristic. Oh my god, what am I doing? So characteristic. Exactly. Good. Okay. All right. Okay. So live link and not on a snapshot here. Exactly. So it is a live link and not an and this is a feature for function and function only. This is a feature of function and functions and function only. Is to help us organize code. That's the whole point of closure. That's the whole point of closure. So not only with this, but also here a different scope here. Exactly. So now it creates a different scope here. From an outer scope. Exactly. So in order to exhibit this feature here, right? And in order to exhibit this feature, this must be is defined as a function expression here. Because it is so common to make mistake closure as value orientated instead of a value or a variable orientated. Developers sometimes get tripped up trying to use closure to snapshot preserve a value from some moment in time. Consider as this. So here the student name is closing over, all right? But it's the student name variable, not the reference here. Not the value, it is reference only. And another example is we're using is a set timeout and so on and so forth. So yeah, the other example is in this. The other example is this. So when you use now here, right? And then you assign now a functions to a function expressions to hopefully store this to hopefully store this I like this, and when you call this, it will give you now is the 3 because it's holding it is reference, not it is value here. And because this is not a block scope, this is a function scope, functions or global scope. This is why when this is now evaluated, all right, all of this instance here are all pointing is to the reference here. And if for some reason we keep calling is here with 3 doesn't exist, and it is interesting here. So the thing here is that it's actually now evaluating each one of them, all right, as expected, okay? So it is now executing is this statement, but when you call now a function like this and try to have a reference to the outer function, have a reference exactly, and have a reference to the outer scope here, exactly, and you want to have a reference to the outer scope, that is going to maintain is the reference, not it is value. This is a common misconception for a lot of us. Absolutely, bro. Absolutely, bro. Absolutely, bro. 3, diggy. That's right. So if I want to decrease this, let's say from 9 to 0, exactly. Yeah, including a 0, that's right. So and then I want to now after an X amount of time is to execute and run those numbers, right? Because what I'm doing here is effectively creating is a closure. Why is that? Because I'm going to reference is uh, I am referencing is the variable, not the value here, uh, because that's what it is, a closure, okay? And when I evaluate this, a timeout here, so if I want to decrease this, so starting from 9, and then so show first 9, and then 8, and then 7, and so on and so forth. So first I need to do is this: hey, I minus 9. I know I don't like use magic numbers. I definitely don't like to use magic numbers. I'm going to use m here and define here n as far and say 9, right? I definitely don't like to use magic numbers, not at all. And var to stop, 0, and is 9 is less than, you're gonna continue, is less than stop. There you go, right? So what I can say is, hey, I minus 9 or minus n, which the first iteration will be is 0, all right? And then times 1000 to say, hey, do that in the first, do that whatever difference you get here, right? I want you to is multiply by 1000 to make it, to convert that into a second. But since n is greater than I, all right, and we want us to provide now a positive number, this is why we take the greatest numbers and then we subtract by the I, right? Which will is decrease at any time, not increase. So here is going to now trigger is 9, my friend. What happened here? Oh, is the stop condition. Exactly. It brings out 0 is because this has been evaluated, is because this 4 has been evaluated and is not creating is a new scope on each iteration. Is just going into, is incrementing, or in this case is decrementing the reference of I, and we are now passing is the reference of I, because this is now evaluated first faster than the set timeout, because set timeout now is putting into the event loop, particularly to the callback queue, and first all of the instruction in the call stack is evaluated until that is empty, and then now you get this. So in order to fix this, because this is a scope issue, the only thing that we can do, or the most straightforward thing that we can do, is to say, hey, let me now effectively is creating is a scope on each one of those iterations, and then I'm going to pass now a new reference to that, right? And now we get that as expected. So this is mind-bending and quite silly and stupid, but it is what it is, man. It is what it is. So, all right. Okay. 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 All right. All right. All right. And You might have expected the keep here invocation to return 0. Since that function was created during the first iteration, the loop when you, well, here is describing is how you can actually fix that. It's by saying, hey, let me now hold a new reference to this and then pass that newly created reference, because it creates now a scope on each iteration thanks to this syntax. Now you are passing effectively is the reference. You are passing now a new fresh reference that holds that value. Okay. So that'll be all for this video. Take care. Bye bye.